Great. So now that we've talked about diffusion and osmosis, we can now talk about passive transport. Passive transport. Now, this is when the cell, where things will go into or out of the cell, but no energy is being consumed by the cell. So this happens completely automatically, completely passively. So if here we have the cell membrane, this is the outside of the cell, this is the inside. You know, again, all these guys are made out of phospholipids with their hydrophilic heads and their hydrophobic tails. You get the picture. Now, the cell needs to get things in and out, and passive transport occurs when the cell doesn't have to spend any energy to get something in. One example of this is when you have tiny little uncharged molecules. So these guys would be soluble in a liquid, in a lipid, but insoluble in water. So let's say they're like tiny uncharged particles. Those guys can actually just diffuse right across the membrane. They have a high concentration on the outside, they'll diffuse right into the cell. That is called simple diffusion. Okay, and that's the first type of passive transport that we'll talk about. The second type occurs when you have, let's say, a big old particle of sugar or something out here. So like a big glucose particle. Now glucose has a charge, so it's going to get repelled by the hydrophobic tails of the phospholipids, and it's just so big it can't squeeze through the plasma membrane. So we're going to need a carrier to get that guy across. And what we have and how this works is you'll have a protein, like a big old protein that hangs out right in the middle of the cell membrane. And that protein will have a spot on it that'll fit that glucose molecule just perfectly. So that glucose molecule will fit right in there. Now this glucose molecule has a charge, and if we remember about proteins, they're just a big string of amino acids that coil up based on their different charges. Well, when that glucose molecule comes in here, it causes the charges to get rearranged, and that protein changes shape. And it changes shape to look like this. So extend it out over this side. So now the protein clump changes shape, and now the protein looks like this. And that's simply because that glucose molecule affected how all those charges combine. Now the glucose molecules on this side of the protein, and it can pop in. Okay. Important thing to remember that this glucose molecule is going down its concentration gradient. So what drives this is a high concentration of glucose on the outside of the cell. It's too big to go in by itself. So what it does, it fits in that protein. That protein is called a carrier. And then that protein changes shape, and now the glucose molecule is on the inside. That type of passive transport is called carrier-mediated facilitated diffusion. Carrier-mediated facilitated diffusion. Okay. So now a third type of passive transport, let's say we have some tiny particles, bunch of tiny little particles on the outside of the cell membrane, just like these guys, but in this case, these guys have a charge. So they're tiny, charged particles. They have a charge, and what that means is that these little phospholipids that make up the cell membrane, all of those uncharged phobic tails are going to repel these charged particles. Remember, these guys are a lipid. These are fatty acids. Fatty acids hate charged things. These things have a charge, so these guys cannot go through by themselves. How they get through is there'll be another little protein in here, but this protein is called a channel protein, and it has a little channel right in the middle that's the perfect size so that these particles can flow right through. And what they'll do is they'll diffuse down their concentration gradient, high concentration on the outside of the cell, they'll come into the cell. All right, but they needed that channel. That's called channel-mediated facilitated diffusion. Channel mediated facilitated diffusion. Okay. Now, the fourth type of passage transport that we can get, this is unique for water. You'll have a special protein, just like this channel protein, but this protein has a tiny little channel in it that only allows water molecules to pass through. So we have a bunch of water out here. Water can fit single file right through this channel, and water will move via osmosis when it needs to. Now this little this little channel protein that allows this to happen, has a special name. It's called an aquaporin. And that type of passive transport is simply osmosis. Okay.